Let's solve one more interesting problem related to matrix, that is word search. Let's see what is this problem. Problem is that given a m into n grid of characters board and a word. So return true if the word exists in the grid. The word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter cell may not be used more than once, right? So let us take one example. This is ABC sub CS ADEF. The word is that ABC CED. So from this cell, and you need to see start from here, and the word should be start word, start character. So that is A, and you can move either horizontally, I'm either top, bottom, left, left only. There is no diagonal. For example, let us take F. From F, either you can go up, either B or C or S or D, not A or not C from F. So let's try to understand this carefully. Okay. Yeah, here the string is this one, right? Okay. Oops. Just a minute. Yeah. So now this is the text we got, and the MNTN matrix is this one, right? Okay. So now we will start from. We will use like a depth first search here. So how to start this is we will start from the 0, 0th position. We'll see we have the options like either you can go in this direction or go in this direction. These are the two options we have here. Suppose if we are here, that is 1 1, then we have options to go at the left, up, or right, or about down. Right? These four directions you can go and check from here uh, which direction actually we can form the given string, right? To build this, what we can do is we'll try to use the directions from this cell. For example, like that x position, this is x and y positions could be like, we'll try to construct this basically the cells indexes from here. Assume that from here, assume that this is 0 0. Okay, and if you want to go up, so what happens, it will be -1 of x, and the position of y should be same only, right? Then this will become this cell position could come, right? Now if you want to back go back here, so here we can go for one step back of the same column, and row will can be decreased now, right? From this position, if you want to go front this direction, then we will have the same position 0, and we can add 1, right? From here, if you want to go down, this time we can increase the column, and the row number should be same, right? So this is the way actually we can construct the loops, and then we need to use the you can try to check the DFS for the each position we are able to get the continuous string or not. For example, from here if you move here, so B is there, and if you come here also, yes, you got it, but this is not going forward, and then reset it back to here. Then here from position A we can go here. From here we can try to see here, this is not matching. Then we have option to go further front forward. We need to reset this back to the string. Why we need to reset is, for example, here it is A, probably here it is B. That time actually you need to come back it actually. So for that purpose we need to backtrack it to get the string from the starting. Okay, cool. So let's try to solve using uh, BFS this problem. I hope you got the idea. So now what we can do here is we'll try to get the number of rows is board, and the number of columns could be length of board of 0. Okay, so now you got the m and n. It's a simple thing. For I equal to 0, I less than m, I plus plus. For j equal to 0, j less than n, j plus plus. Just we need to do is we need to write a DFS for this. DFS of board I comma j, and the word whatever we got from there. Okay, if this is true, then return true. Otherwise no need to do anything, return false. That means we are not able to find that particular word in that particular board. Okay, let us write a DFS method which will take board of bytes, right, and indexes on followed by the word whatever we received it, word of type string. Okay, here we need to return bool. Cool. So suppose if the length of the word is 0, nothing to do anything here, return true. This is the base condition. And also we need to again get the length of the board, actually rows, columns. We get that. Once we get this, as I discussed here, to construct the positions of the x and y to uh, get that, so we can try to do the x of integer of index is, as I mentioned, -1. Let me see, -1 0 0 1, right? 1. Similarly, y position could be integer of 0, -1, 1 and 0, 0 -1, 1 and 0, 0 -1, 1 and 0. Yes. Okay. So we got this. Now we'll try to check the index is within the range or not. I should be less than 0, or I should be greater than or equal to m, or j less than 0, or j is greater than or equal to n, and board of I of j is not equal to word of 0. That means this is not the starting position, then return false. Okay. Otherwise, what we can do is we need to see, just check the, here actually we need to see the backtracking thing. We need to get the current character at position I and j. Okay. So once we are done with this, then we need to mark that position as visited. Okay. Probably we can take like a asterisk or hash or something. Okay. Now we need to see remaining word. Are we able to uh, match or not from one to remaining string? Okay. Let us see, like a result could be like a false by default. Now let us have a for k equal to 0, k less than 4, k plus plus. Here we need to iterate the entire this particular positions from IJ and try to see we are able to find the respective string or not. Okay. So for this, what we need to do is our result or DFS of board comma I plus x of k is one position and j plus y of k comma word. I mean remaining word. Okay. So if this is actually recursively we are calling with all the four positions and try to move further actually from there. In case like we reached F and further we are not able to move, in that case actually we are trying to fill the character back, whatever we stored here, right? Here. So and then we will return the result. That's it. Yeah. Let's see. Syntax error, board expected. Expected. Okay. Yep. Our condition is missing. Let's see any other problems. Yes. So that's it. Okay. Yeah. So the time complexity of this solution is yeah, m into n, uh, and also we have the recursion here. So this also will take to the power of n. Yeah, that's it.